So in this video, I'll show you how to use z-scores to compare two values that otherwise might not be so easy to compare. So in example 4, we have Bill, who plays for the Silverhawks, and he scores however he scores. And then he has his friend Ryan, who plays for the Red Hawks, and he has like the points and stuff that he has. Now they're arguing over who's more valuable to their team. So to compare them, because one of them could be on a softer team, so you want to see who's more valuable to their team by using z-scores and standard deviation. So on the left side, I'm going to do Bill. Okay, on the right side, I will do Ryan. Okay, all we really need are the z-scores, plain and simple. We don't need it. We won't need the z-score chart to do this. So Bill's z-score. Let's see. He scores 8 points a game. So that's his value minus the average, which is 6.5. Okay, standard deviation of 1. Okay, what does that turn out to be? What's that z-score? 1.5. Okay, so that's 1.5. So he scores 1.5 standard deviations above average. That's a very large chunk. So Bill's looking pretty good so far in terms of being valuable to his team. Now let's see, what about Ryan? Ryan scores also 8 points per game. So that sounded familiar. The average points on his team is 5 points. Standard deviation 1.5. What does this come out to be? 2. Okay, so that dominates even more. That's 2 full standard deviations better than the average teammate. So clearly Ryan is more valuable to the team because he has the higher z-score, 2 standard deviations above average. All right, any questions on that before I slide down to example 5? Okay. Now, let's do the same thing. It's real similar. We will need the z-score chart for this one. We're talking about pizza, okay? These guys are delivering pizza. Let's see, how long do they have before it's free? When do the free pizzas kick in?
45 minutes after.
Okay, the free pizzas kick in 45 minutes after it's ordered. So we're going to do our calculations to figure out what percentage of Ben's pizzas are going to be free and what percentage of Jim's pizzas are going to wind up being free. So that way we'll see who's giving away more free pizza. One quick little calculation we have to be careful of. This chart is giving us delivery time, like the time it takes to drive it from the store to the people. Now, it takes 15 minutes to prepare the pizza in the first place. Okay? So in terms of the 45 minutes that we have to keep the pizza from being free, we're automatically going to use up 15 minutes. So how much delivery time does it take before it's free then? 30 minutes are all we've really got. Not 45. 15 minutes are automatically going to be burned by the making of the pizza. So in terms of delivery times, 30 minutes and it's free. Okay? So basically, we're going to use 30 minutes, find the z-score, and then we'll find out what percentage of each person is over 30 minutes, because that's what would be free. Okay, so I'll do Ben's calculations over here, and I'll do Jim's calculations over here. So let's start with the z-score. All right, so Ben's z-score. Okay, so his average delivery time is 12. Okay, that's his delivery time. Wait, no, I'm saying this wrong. Start over. The average is 12, so that's what I need to be subtracting. What we want to know about is a delivery time of 30 minutes, all right? Because that's when the free pizzas start happening. Okay, so we want to know what about 30 minutes. So 30 minutes minus 12 divided by a standard deviation, which is 10. Okay, can somebody calculate that for me real quick? Okay, so that's a z-score of 1.8. Now, I want to know what percentage of Ben's pizzas are going to be free. So I want to know what percentage of Ben's scores go above this. So what percentage of the values are over 1.8? Because that's where the free pizzas start, when he takes longer than he's got. Is this a situation where I'm going to read the percentage right off the chart, or is this where I need to subtract from 100? This time you have to subtract from 100. Greater than 1.8 is what we're looking for. Okay, so we go to the chart. We find 1.8. Okay, so here's 1.8 down here. Oh, we wanted exactly 1.8, right? So that means we'll just go with the first column, which is the 0 column. So that's 96.41. But like you said, we need to go 100% minus 96. Was it 96.41? Okay. So this is about to tell us what percentage of Ben's pizzas are free. 3.59%. Okay? So a little over 3.5% of Ben's pizzas are free. Free pizzas. Okay? Now let's see how Jim does in the same kind of calculation. So Jim's z-score, we still want to know about 30 minutes because that's when they start being free. But his average is 15 minutes and his standard deviation is 6. Okay, can you calculate that out for me? 2.5 exactly. Okay, so 2.5. And we want to know the percentage of values that are, again, greater than 2.5, because that's where they start being free. So, of course, again, we're going to have to subtract from 100 when we do this. So find the 2.5. Okay, so that's right here. All right, I mean, you see the 2.5. Hold on. This makes me nervous. So here's the 2.5, and we want the 0. So we're subtracting 99.38%. All right, what do you get when you do that subtraction? 0.62%. So this is Jim's free pizza. So obviously, who's giving away more free pizzas? Yeah, Ben is giving away more free pizzas than Jim. All right, let's do one more. Oh, this is the last problem on the paper. Yay. Okay, Lewis earned 85% on his test and 80% on his history test. Wait, 85% on the biology test, 80% on his history test. In his biology class, the mean was 79, standard deviation 3. History class, 76, standard deviation 4. What percentage of the class was below Lewis in biology class? Okay, so we're talking about biology class. We're going to do z-score. So biology class, he earned an 85. So here we go, 85. See, biology class, the mean was 79. Standard deviation 3. Okay, what's that z-score? 2. Okay, so what percentage of the class scored below? So in this case, can we read this right off the chart, or do we need to subtract from 100? We can read it right off the chart. So the percentage of z-scores less than 2 is what we want. Okay, right, because here's the 2 right here. So that's 97.72%. Okay, part B. What percentage of the class was below Lewis in history class? All right, let me switch colors for history. Okay, z-score again. All right, so you got 80% on his history, so 80 minus. History class, the mean was 76, and the standard deviation was 4. What's the z-score, guys? 1. Okay, so we want to know what percentage of values are below 1. Okay, we don't have to subtract from 100. It's 84.13%. Okay, so on which test did he do better compared to the rest of the class? Obviously, biology. He was at the 97.72 percentile. There, you could use that word percentile since we're talking about below.